movable discontinuity. So these problems are the one that you're going to see on the AP multiple choice question. For example, it says, it is known that the limit as x approach 4 of f of x exists. F of x is continuous on the interval negative infinity to infinity. That just means that the function is continuous for all real numbers, okay? I want to find the value of k that make that happen. So the limit as x approach 4 exists. The function is continuous for all value of x. Yes? Find k that make that true. So this is what we know. Because we know that the function is continuous, that means it needs to satisfy all three criteria. The point exists, the limit exists as x approach 4, and the point at x equal to 4 is equal to the limits as x approach 4 of function f. Are we good? So to find k, all you have to do is do one thing for me. You're going to check the limit, because the limit have to exist. So we make that assumption. All right, so since f of x is continuous on the interval negative infinity to infinity, the limit as x approach 4 of f of x have to exist. And it says that right there already. Okay? And even if it doesn't say it, you know the limit have to exist. So based on that, what I'm going to do now is I am going to find my limits. Okay? As you can see here, this is a piecewise function. You have the left end and the right end. Do you guys see that? The left function and the right function. So we're going to have to break this out into the limit as x approach 4 from the left of the function f, and on the left is going to be x squared minus k. We're going to find that by, we can't simplify, so we're going to just plug in the 4. So if I plug in the 4, I will get 16 minus k. And then on the right end, the limit as x approach 4 from the right is negative 3x plus 18. That's the function I'm going to use. And then we're going to plug that 4 in for x. So I have negative 3 times 4 plus 18. Negative 3 times 4 is negative 12. Plus 18 is going to be 6. Yes? Since the limit exists, that must mean the limit from the left and from the right have to agree. And therefore, we can say 16 minus k is going to equal to 6. And then you solve for k. Okay? So if I were to solve for k, I would move the k over here first by adding k over. So I will have 16 equal to 6 plus k. Yeah, I'm going to move the k over. And then I'm going to subtract the 6 over. So that will be 10 for k. And there's your answer. Any questions on that? Okay. So again, what do we just do? Well, because the limit as x approach 4 exists, and we also know that the function is continuous, we can find k by just looking at the limit alone. Do I need to look at the point? No, because I know that since the function is continuous, the y value of the point and the y value of the limits have to be the same. So I don't need to look at the point. You guys see that? Any question? All right, let's move on to example 2. Go ahead and read that first. Okay. It says calculator is allowed, so you're going to have to grab a calculator for me. So go ahead and grab a calculator. All right, let's take a look here. It says, given function f, notice this is a piecewise function. K is a constant. So constant means k is a number. Okay? For what value of k is the function f continuous? So I want to know a number for k that make my function f continuous on its domain. That means we're going to assume, to find k, we're going to assume that f is continuous. Okay? On its domain. Now, what is the domain? That means, well, it's from negative infinity to infinity, because here you are including 5. Do you guys see that? These are anything less than 5. These are the function where x is anything greater than 5. So we're looking at all real values here. Okay? So your function is continuous from negative infinity to positive infinity. But right now, we're only going to focus on k. So this is not really important. But it's important to know that we have to make this assumption in order to find k. Same idea. In order for the function to be continuous, it needs to pass all 3 checks. The one that we're going to use is looking at the limits as x approach 5 from both sides. Yeah? Because you have a piecewise function where your left and your right functions are different. We're going to have to look at the left and the right end. So this is the limit as x approach 5 from the left end. And that is going to be the function 12 over k to the third plus x. What we're going to do is we can't really simplify. You can see that because you have a 12, right, a constant on the numerator. So all we're going to do is plug in x, which is 5. Okay. Understand that that negative only tells you that you are approaching 5 from the left. It's not a negative 5. The value is still a positive 5. So keep that in mind. All right. So we got the left end. Now we're going to take a look at the right end. On the right end, the function I'm using is k squared minus x. So that's going to be k squared minus 5. Since the function is continuous, the limit as x approach 5 need to exist. And therefore, the left end have to agree with the right end. That means you have to set them equal and then solve. All right, use your calculator to solve for me, please. Use your calculator to solve for me, please. So we're going to go to NumWorks. Hopefully you guys remember that. If not, I'm going to show you how to do that again. We're going to go to equation. You guys remember that? And then I'm going to type in the equation, right? So we go, this is 12 divided by, we don't have k, we have x. So we're going to use x to the third plus 5. And then that's going to be equals 2. And your equal sign is right there. But you got to go shift and then the equal sign. All right? And that's going to be k squared. So we're going to go x squared minus 5. All right? We're going to solve, and there's our answer. You guys see that? Don't show this for to my Algebra 1 kids. They're going to be using this all day long. There you go. And that's your answer. 2.377. And the answer should be D, right there. Any questions on that? No? All right, so we are done with 113.